All right, let's get started. So today we want to talk about section 4.3. Any questions? Yeah. Oh, I'm sorry. I kept
Number 31.
31? Yeah. Okay, number 31. So we want to find the intervals on which f is increasing and where it is decreasing for 31. Okay. So number 31, we have f of x is equal to negative 2 cosine x minus x on the interval 0 to 2 pi. Okay. And we're trying to find where it's increasing and where it's decreasing. Okay, so the first thing that typically we want to do when we're finding where a function is increasing and decreasing is find all the critical values, okay, and then put them on a number line. So let's go ahead and do that. So we'll start by taking the derivative. So the derivative of negative 2 cosine of x is 2 sine x, and then the derivative of negative x is minus 1, correct? And then what we want to do is find the critical values by setting this equal to 0 and solving for x. So if I set that equal to 0, then I can solve and I get that 2 sine x is equal to 1, or sine x is equal to 1/2. Okay, so the question is, where are the x values in between 0 and 2 pi where sine of x is equal to 1/2? And there should be 2 of them, right? Because sine is positive in the first quadrant and in the second quadrant. So what are the 2 x values that give a sine value of 1/2?
What's the negative?
Not quite, no. Yeah, pi over 6 is one of them. And what is the other? Yeah, 5 pi over 6. Very good. So 5 pi over 6, and that's it. So these are the 2 critical values for this function. And so what I want to do is I want to put the critical values and on the original number line. So here's my original number line. This is 0, this is 2 pi, and then I want to put pi over 6. Let's see, I suppose that's pi. So pi over 6 isn't very far at all, and 5 pi over 6 is pretty close to pi. So here's pi over 6, here's 5 pi over 6. And so now what we want to do is, this is where the derivative is 0. This is a little chart for f prime. And we want to test some points in between these 3 regions to see, is it positive or negative, or in other words, is it increasing or is it decreasing on that interval? Okay, so what should we test here? Maybe the easiest thing we could test is just test pi. And we're testing it in the derivative, right? So we want to see if we plug in pi to the derivative, and maybe let's just remind ourselves what the derivative was. F prime of x was 2 sine x minus 1. Okay, so we could test something like pi. If we did, what's sine of pi? 0. So it's just 0 minus 1 is negative, correct? And so everything in here, in this region, will be negative. Okay, we could test something. What's something between pi over 6 and 5 pi over 6 that might be nice to test?
2.
Yeah, pi over 2 seems perfect. If I test pi over 2, sine of pi over 2 is what? 1. 1 times 2 is 2. Minus 1 is positive 1. So things in here are positive. And then I need to test something that's smaller than pi over 6, which is kind of a hassle because pi over 6 is kind of like our smallest nice place to test. But if I did test something smaller than pi over 6, what can you tell me for sure about sine of x? What's it less than? So what is, by the way, so what is sine of pi over 6? 1/2, right? So if I take something smaller than pi over 6, remember on the unit circle, pi over 6 is right here. If I took an angle that's smaller than that, then the y value is going to be even smaller than 1/2, right? So if I take something smaller than pi over 6, then this is going to be less than 1/2. 2 times something less than 1/2 is less than 1. And so minus 1 is going to be negative. So I could just say those are negative. Okay, so I don't necessarily, if you didn't like that, you could just plug in pi over 12 or something and use your calculator, but we can kind of think it through and see if it would be positive or negative. Okay, so now we have our chart, and now we're ready to just write down our answer. Anywhere where it's positive, we're increasing. Anywhere where it's negative, we're decreasing. So we could say F is increasing on the interval from pi over 6 up to 5 pi over 6. And F is decreasing on the interval from 0 to pi over 6 and from 5 pi over 6 to 2 pi. And that's what we're going for. Sound good? Any other questions? Yeah.
On 17, right?
Yes.
You get to the second derivative, there's no x component, and once the second derivative test of 17, it's not possible.
On, did you say 79?
Yeah.
Okay, let me look. Yeah. Oh, so are you saying there are no critical points?
Well, I mean, we get the critical point from the first one, and so there are, but then the second derivative is constant.
That's right. So when you plug it, so it's just a constant, the second derivative?
Yeah.
Yeah, so when you plug in the critical point, it's that constant. So it's either positive or it's negative, which will tell you if it's concave up or concave down,
Okay.
depending on what, or I guess in this case, they're looking for, is it an absolute max or an absolute min, right? So if it's negative, it's an absolute maximum. Positive, it's an absolute minimum. But just because it's constant, that's okay. That just tells you that it has a constant. What does it come out to be, positive or negative?
Negative.
Negative, okay. So it has a constant negative concavity, right? Which just means that it's always curving down. So something that's always curving down, like here's an example of something that's always curving down, right? But that means it must have if it does have a absolute max or min, that must be a max, right? Similar, if something were always curving up, then the only way that it could have an absolute max or min is this, if it had a minimum. Does that make sense?
So when it says if the second derivative test is possible,
Yeah.
it's only not possible if you completely derive out the number, I guess. Like, I don't know if that makes any sense.
Well, what I would say by is the second derivative test possible is, do you get a positive or negative value out when you plug in the critical value? If you got a 0, then it would be kind of like, I don't know if it kind of failed if you get a 0, but as long as you get a positive or a negative out, it didn't fail.
Okay.
Yeah. Other questions? Yeah.
Can we do 35?
35, sure. So we have f of x equals x to the 2/3 times x squared minus 4. Okay. So 35, we have f of x equals x to the 2/3 times x squared minus 4. 5, x squared minus 4. Okay, so we want to find where f is increasing and decreasing. All right, so the first thing we need to do, right, is we just need to find a derivative, set it equal to 0, solve for x if we can, and find the critical value. So let's do that. So f prime of x is equal to, now, one thing that I could do is I could use the product rule here to take the derivative, or I could just multiply it out first and then take the derivative. And either way is fine. I think life becomes just a little bit easier for us if we multiply it out first. And so what's x to the 2/3 times x squared? I suppose I add those exponents. So what's 2 plus 2/3? 2 is 6/3 plus 2 more thirds is 8/3. So this is x to the 8/3. And then x to the 2/3 times minus 4 is minus 4x to the 2/3. Correct? Okay, so we could just take the derivative of this, which seems much easier. So I will, and I get 8/3 x to the 5/3. I subtract 1. And then for the second one, I get minus 2/3 times 4 is 8/3 x to the negative 1/3. All right. So having an x to the negative 1/3 is interesting because that means I could possibly plug in 0 and get division by 0. So what I probably should do is rewrite this. I could take out the 8/3 just to get it out of my way. And then I have x to the 5/3 minus 1 over x to the 1/3. And now if I wanted to, I could get a common denominator. So let's do that. And I get that this is 8/3 times, if I put an x, multiply top and bottom here by x to the 1/3, and the top becomes x to the 6/3, which is just x squared, minus 1 over x to the 1/3. Okay, and this is a great place to stop because this gives us all the information that we need. Like where is x? What x's would make this thing 0 is pretty obvious now from the top that it would be 1 and minus 1. And what would make it undefined if x is 0, right? So we get 3 critical values for this thing. We get that x equals minus 1, 0, and 1. And so we should put all of those on our first derivative number line. So here's f prime, and we have minus 1, we have 0, we have 1. And now we just need to test some points in between to see if we get positives or negatives. What should I test? How about, let's start with something over here like minus 2. Now I could test it here, I could test it here, I could test it here. All of these are the same. I like this one better because all I care about is if it's positive or negative, right? So if I test something like minus 2 squared minus 1, that's 4 minus 1, that's positive. So I'll just put a little positive on top to keep track of what's going on here. And then if I take the cube root of a negative number, is it positive or negative?
Nice.
Cube root is not imaginary.
Oh, it's
So can you cube a negative and get a negative? Yeah, so like -1 cubed is -1, right? So the cube root of something negative is something negative. So the bottom would be negative. Okay, so we get a positive over a negative, which is negative. So we just get negatives here. Now, if you don't like the way that I do it, that's fine. If you don't like it, that I don't care about the number, I just get if it's positive or negative. This is easier for me, but if for you it's easier to just plug in an actual number like number 2, the number -2, and just see what comes out, and then see if it's negative or positive, that's great. Whatever makes the most sense to you is perfect. So then I want to take something that's in between -1 and 0. How about -1/2? Okay, we already said that a negative number cube rooted is negative, so the bottom's negative. And then 1/2 squared is something, -1/2 squared is something like a fourth, -1 is negative. So I get a negative over a negative, which is positive. So these are positives. Then I could take something like a half. A half cube rooted is positive, and a half squared is like a fourth, -1 is negative. So negative over positive. These would be negative. And then let's test a number like 2. 2 squared is 4 -1 is 3, which is positive. And the cube root of 2 is positive. So these would be positive. And so now we just need to write down our answer. And that is that F is increasing on the interval -1 to 0 and from 1 to infinity. Also, F is decreasing on the intervals from -infinity to -1 and from 0 to 1. And that's it. Any questions? Let's see, somebody wrote something here. Can we do 47? Okay, yeah, 47. Let's look at that. Okay, so 47, we want to find all the critical points, then use the first derivative test to locate local max and mins, and then identify the absolute maximum and minimum values of the function on the interval, if they exist. Okay, so this was 47. So we have so 47, we have f of x is equal to x times the square root of 4 minus x squared on -2 to 2. And we want to start out by finding the critical values of f. Okay. So to find the critical values, I need to take a derivative and see where that derivative is either 0 or undefined. Okay. There's no fancy tricks to do here, unfortunately. I just have a product, and so I do need to use the product rule. I suppose if you wanted to be very clever, you could bring the x inside as an x squared and maybe get away with a little less of a derivative, but I think it's okay. So we'll take the first one, x, times the derivative of the second, which is 1/2, 4 minus x squared to the negative 1/2, times the derivative of what's inside, which is minus 2x, plus the second, which is the square root of 4 minus x squared, times the derivative of the first, which is 1. Okay, so that is the derivative, but it's in a very, very bad form. Okay, so let's rewrite. So if I wanted to rewrite this thing on top, I see I have a 2 here and a 2 here. So I have a negative x on top. And on the bottom, I have a square root of 4 minus x squared. And then I have plus square root of 4 minus x squared. And again, I think when you get these square roots in here, it's good if you can to combine into one fraction, because it just makes it more clear what the critical values are. And so I could get a common denominator of square root of 4 minus x squared. If I do, then I get negative x. And if I multiply top and bottom of this by square root of 4 minus x squared, the top will become 4 minus x squared. And the bottom will have a square root of 4 minus x squared. Okay. We could simplify that even more. And we get, let's see, on the top I have negative x squared minus x plus 4. And on the bottom I have the square root of 4 minus x squared. Okay. So the question is, what makes the top 0 and what makes the bottom 0? First thing I can see is on top, I could factor out a negative 1 if I wanted to. Let's do it really quick. So this is minus x squared plus x minus 4 over square root of 4 minus x squared. Does this guy factor? Let's see. It's not so nice, right? It almost makes me wonder, did I do something wrong? I just want to make sure that I didn't do any of my math wrong here. So I had a negative x on top here, and then when this is done, I get 4 minus x squared. Yeah, everything looks good to me. Okay. But I don't see any really nice way to find, to factor the top. The bottom, it's obvious what makes the bottom 0. So those are two obvious critical values. But the question is, are there any more critical values on the top? If you can't factor it, how would you find the two things that make the top 0? Yeah.
Or back it, or what happens to the x in the front?
Yeah, I think it's negative x squared over 4.
Oh, the square. I knew something wasn't feeling good, and that's going to make a big difference. Yeah, thank you. So that's a square, that's a square. And then I'm going to get minus 2x squared. Plus 4. Am I seeing this right now? I think so. Yeah, this is much better. Thank you. And then this one becomes minus, I suppose I could factor out a minus 2 if I wanted to, and I get x squared minus 2. Does this seem good? Okay, now we're in a position where I can easily read off what the critical values are. So my critical values are the things that either make the top of the fraction 0 or the things that make the bottom of the fraction 0. What makes the top of the fraction 0? Yeah, plus or minus the square root of 2. So I've got x could be negative square root of 2, or it could be positive square root of 2. And then what makes the bottom 0? 2 or minus 2. Yeah, so 2 and minus 2 are also critical values. So we get these 4 critical values. So we need to put them on a number line. Oh, I guess I should read the problem because that may not be what we're doing. So I found the critical values. So the second piece of this problem was, let's see, which one was this? 47. Okay. So 47, we want to find the critical values. We did that. Use the first derivative test to locate the local max and local min. Okay. So we still need to put these on a number. So the number line helps us in the first derivative test. Here's my first derivative. I put these 4 values on. I've got minus 2, minus root 2, root 2, and 2. And then I need to test some numbers in between into the first derivative, which is sitting right here. Yeah.
Because the interval is plus or minus 2, you just not test.
Yeah, true enough. I still, yeah, I don't need to test then out here or out here, right? So all I care about are these 3 intervals because we're on that interval. Okay. So, and here is my first derivative, although it's like a modified form, but I think it's an easy place to test. Why don't we just start with the easiest thing I can see to test, and that's 0. So if I put in 0, the whole top would be positive or negative. If I plugged in 0. Positive, because this would be negative 2, this is negative 2, so the top is positive. If I plug in 0, what happens on bottom?
Positive.
Also positive, yeah. So we have a positive over a positive for 0, so this region, we get positives. Okay. Let's try something bigger than the square root of 2. Okay, so what's helpful here is if you're slightly bigger than the square root of 2 and I square the thing, is it going to be bigger than 2 or smaller than 2? If you take something slightly bigger than the square root of 2, it will be slightly bigger than 2. So something slightly bigger than 2 minus 2 is positive, times a negative is negative. And then down here, 4 is 2 squared. So if you're in between square root of 2 and 2, and I square you, you're still smaller than 4. Okay, so this is going to be positive. So we get a negative over a positive, which is negative. And then we could do the same thing for something in between negative square root of 2 and negative 2. But nothing really changes because this is squared and this is squared. So it's just going to make it positive anyway. So we'll get the exact same things. We get negatives. Okay, so the first derivative test just has us read off of this where are the local max and mins. And what I always like to do is I like to remind myself, so it's going down, then it's going up, then it's going down. And that's just like a little like mini graph of my function, although it doesn't have the curvature right in any way, but it shows it goes down, then up, then down. But that helps me because if it goes down, then it goes up, then that point must be a local minimum. So I can say that F has a local minimum at X is equal to negative root 2. And then here we see it's going up and then it turns and starts going down at the square root of 2. So F has a local maximum at x is equal to the square root of 2. Okay, and that was the second piece. They say use the first derivative to locate local maxes and mins. And then it says identify the absolute max and min of the function on that interval. Okay, so to find absolute max and min, so we found some local max and mins, but we don't know that they're absolute. But where could absolute max and mins happen? Well, if we remember back a section, they can happen at critical values, or they could happen at endpoints. So we just need to test all critical values, which are these two, and all endpoints, which are these two. So we just need to find what's f of -2, what's f of -√2, what's f of √2, and what's f of 2. And then just see what ends up being, and this is going back into the original function, right? Not into the derivative function. So if we were doing this, what's f of -2? I suppose that it is -2 times the square root of 4 minus -2 squared is 4. So this is 4 minus 4, that's 0. F of -√2 would be -√2 times the square root of 4 minus the negative square root of 2 squared is 2. So 4 minus 2. So this is -√2 times √2, which is -2. Then we have f to the square root of 2, which is square root of 2 times the square root of 4 minus the square root of 2 squared, which is 2. So this is √2 times √2, which is 2. And then finally, what's f of 2? It's 2 times the square root of 4 minus 4, which is 0. So it does end up that this guy is an absolute minimum, and this guy is an absolute maximum. And we could write that out, that f as an absolute maximum at, maybe I should say of, 2 at x equals √2, and f has an absolute minimum of -2 at x equals -√2. And we're done. Yeah.
Won't the absolutes, for finding the local maximum mins in a given range, won't the absolutes always be the same as like x value as the local?
Not necessarily, no. So let me show you a quick example of something where that wouldn't be the case. So let's say that I had this function. So here's my interval from A to B, and let's say we're just living on that interval, and we're up here and we do this sort of thing. So here's a function, and it has a local minimum here, right? It has a local maximum here, but then its absolute max is over here, and its absolute minimum is over here. So it could be, but what we had in our function just now is it did this sort of thing. So the absolute max was the local max, and the absolute min was the local min, and the endpoints were nothing. But it could be, or it could be one of the two, right? It could do something like this, where the absolute max is an endpoint, the absolute min is a critical value. It just depends. So you still, when you're doing absolute max and mins, the endpoints get to play. Yeah. Other questions? Somebody mentioned 99. Okay, so on 99, they ask you to match functions with derivatives and then match it with its second derivative. Okay, so one thing, let's take a quick look at this. And if you don't have your book right in front of you, it's a little bit harder. Maybe I'll draw them really quick. So. So they give us three functions, and I'll draw them. The first function looks something like this. Then the second function looks something like this. It's kind of like a W of sorts. It goes down and then up and then down and then up. And then the third function looks something like this. Okay, so without even looking at the next set of functions, what can you tell me about the slopes of all of the things on this first function? They're all positive, right? Every single slope, except possibly at this one point, that might be 0, but it's positive slope, positive slope. So it's kind of like all of the slopes are positive. So you would kind of want to find a function in which, for the derivative, where all the slopes are positive. So the only one that I see in the second set where all the slopes are positive kind of looks like this, and it's 0 at that one point. And we said the slope could be 0 at that one point, but all the slopes are above the x-axis, so they're all positive. What about this one? Are all the slopes positive on that guy? No, it kind of is like it's negative slopes, then it's positive slopes, then it's negative slopes, then it's positive slopes. So it changes back and forth. So it's kind of like it's negative slopes, then it's positive, then it's negative, then it's positive. So see, these are negative slopes, positive slopes, negative slopes, positive slopes. So this matches up with this guy, this matches up with this guy, which means this one, it's negative slopes, and then it switches to positive slopes. So it must be negative, and then change to positive. So you can kind of look at the slopes themselves and say, are these positive or negative slopes at different places? And where is the slope 0? Even that alone could kind of help you to get this, in that this has 3 places where the slope is 0, and this has 3 places where the slope is 0. So that can help you to match it up. And then if you want to do it again for the second derivative, well, here, this is very much the same curve as this, right? Pretty much. So you would expect its derivative to look like this, which it does. Okay, the second one, what does this guy's derivative look like? Well, how many times does it hit 0? Twice. So that should help, that it goes through 0 twice in its derivative. And then this one, well, this is just the same slope everywhere. So you would expect the derivative to just be some constant function or just a straight line. So I'd expect the derivative of this one to be a straight line. I'd expect this one to go through 0 2 times. So let's see, it would do something like this, where that's the x-axis. And this one's going, it's negative than positive, so I'd expect it to look something like this. All right. So hopefully that's helpful. Okay. Any other questions? All right, that's good for today then. I will get some homework posted on the next section, and we will talk about that section on Monday. Of course, just a reminder, next week we only have 2 days of class, right? So just Monday and Wednesday. Have a good day, and I will see you there. Yeah.
This next section on my head is 2 lectures and then 1 homework drop. Is that?
Yeah, let me take a quick look at that. So, okay. Yeah, I may modify it a little bit online. It may change.
So do we watch both lectures or just?
I'll post it clearly,
Okay.
whatever it is.
Sounds
It will be posted clearly so you know which is due on what day.
Cool.
Yeah, but don't do, just wait until I post it in. Should be clear.
Take a picture of the answers just to check.
Oh, yeah, sure.